So thanks a lot for coming to my talk. I looked at the schedule and I wanted to go to all of the other talks at the same time, like every single one of them. So what I'm going to talk about is CoCalc, and I'm going to focus specifically on real-time collaboration. So this is the kind of overview of the talk. So I'll just give you some quick background, quick demo, talk about the architecture of CoCalc a little bit, and then I'll focus a lot on how real-time sync works. And then I'll probably be out of time, but if not, I'll also say some general things about the range of functionality in CoCalc, some issues about the culture of CoCalc, and we're done. So just a quick bit of background. I spent the last 6 years on this project. So you can see my kind of commit history on GitHub. So I've committed a lot of code kind of frequently over the last 6 years, specifically to the CoCalc GitHub repo. And who am I? So I started a project called SageMath in 2004, which is a large Python library for primarily pure mathematics research and also undergraduate mathematics-related teaching. It's meant to be an alternative to Mathematica, Maple, and Magma. I also started Python, which is a Python to C compiler, and it makes it easy to write, or it makes it possible to cleanly write very fast code and use it from Python. And then I started something called the Sage Notebook in 2006, which it looks a lot like, I guess, what Jupyter looks like now, but it was written using kind of before jQuery even existed. So it was pretty tricky to write. I'm a mathematician, as was just mentioned. So I've been at a couple of universities, Harvard, UCSD, and University of Washington, and I'm currently a full professor there, though I've been on leave for the last 2 years as the CEO of SageMath, Inc. Okay, so first, I'll show you a quick demo of CoCalc. I'll probably spend about 10 minutes on this. So I'm going to exit this page, and I'm logged into CoCalc right here. You can see a list of my projects. Of course, I'm a collaborator on a lot of CoCalc projects, on hundreds and hundreds and hundreds of projects. With each project, there's a title, when it was last actively used, and the people that are collaborators on those projects. A CoCalc project is just a Docker container and a file system associated to it that's persistent over time. So let's make a brand new project, demo for JupyterCon 2018. And then I'll create the project. So this is now creating a file system specifically for this project. It uses ZFS under the hood so that there are snapshots of the file system every few minutes, so that if you invite a collaborator and they stupidly delete everything, you can revert to how it was a few minutes ago. It then starts up a Docker container that's pointed at the project. And now let's create a couple of documents. So I'll just make a Sage worksheet, a Jupyter notebook, a LawTech document, a Stopwatch to keep track of what's going on today. Start that running. A terminal, a command line terminal, a to-do list, and you can also manage a course. You can chat with people. Hello. The people you would be chatting with are the collaborators on this project. Since I just made the project, I don't have any collaborators, but if I did, I would be chatting with them here. And there are editors for many different document types. So you can see them listed here. Some of these are just, well, it's a code mirror editor with syntax highlighting and code folding. Others, though, are quite sophisticated. For example, there's RTech. So if you click there, you get a new .rtech file. You have an editor on the left, and then a preview on the right, though you can switch it around however you want. It uses knitr so that you can put arbitrary R code in your document and see the output. Okay, so that's kind of that's a sort of 2-minute whirlwind tour. Now let's look a little more closely at some of these other documents I just created. Everything here is happening online on CoCalc.com. So here are some other documents. Let's start with a Jupyter notebook, since after all, we're at JupyterCon. So these are the kernels that we have pre-installed in our Ubuntu 18.04 environment. So we support all of these, test them, etc. So I'll choose Python 3 Anaconda 5. And there we are. And then I can do some simple calculation like 2/3 plus 3/2 hit Shift-Enter. It starts up the kernel. There's some CPU, and then you get the result. By the way, try 2/3 plus 3/2 in Python 2. It's pretty fun. You end up with 1. So this should look a lot like the normal Jupyter interface. The menus are pretty similar, though slightly different. So for example, there's a cell menu, but instead of having submenus that you have to go to and then having things pop out and then you have to go over to them, everything's just in a single menu like this. So what we did with CoCalc was take Jupyter, look at all the functionality, and then do a complete rewrite of it using React.js. So that's what you're looking at here. And we did that because we wanted to fully support real-time sync properly, and it's very hard to monkey patch that into the standard Jupyter implementation. Let's see, a flashier example. There's an assistant. This is just some extra thing that we added. It has thousands of examples of code for each of the different kernels. So let's do something with graphics so it's more impressive. Visualization, I don't know, matplotlib example, contour plot. So you could say insert example, and then it will put it in there and evaluate it. And here's the result. If I click back here on the Files tab, you'll see I've created a lot of files just in the last few minutes. There's RTech files and the auxiliary files associated to them. There's the Jupyter notebook, and there's all these other things that I created. Some other unique things. So I'm just back in the Jupyter notebook. There's this big blue button labeled Time Travel. If you click on this, it pops up another tab, which is the Jupyter notebook, but with a slider. And what you can do is you can move the slider anywhere, or just move it along, and it has the complete evolution of the Jupyter notebook over time. And you can also ask for a diff. So tell me exactly what changed from one point in time to another. And what it does is it just puts the Jupyter notebook in a diff-friendly JSON format and then shows you the diff. So I'll show you a little bit more. Here's a Sage worksheet. So again, do a quick evaluation. It has to start up a server for Sage in the background. We do support doing a lot of things besides just using Sage. For example, you can use any Jupyter kernel from within this worksheet. And there's also this assistant with lots of examples. And things like 3D plotting, et cetera, work very nicely here. So for example, here's an implicit 3D plot. And here's a graph. So you can see it just pops up in your browser. You can move it around. It uses 3JS, so it's very fast and lightweight, et cetera. You can do stuff with graphs, vertices, and edges. So let's say we want a random graph. So just click that. It makes a random graph with 15 vertices and 20 edges, then uses D3 to display it. So this is a Sage worksheet. It's pretty similar to Jupyter notebooks. Jupyter was sort of really getting off the ground about the same time that I started writing Sage worksheets. And Jason Grout and I, in fact, talked a lot about the design, how you switch from one mode to another, et cetera. Sage worksheets are neat because you have a single document. Instead of having a whole bunch of separate cells that are each individual editors, you have one single document. So you can sit there and do things like select a range. Oops. You can select a range that includes part of one cell, the output of another cell, et cetera. Do copy, and then go to another worksheet somewhere else, or the same one, and then paste it. So it's like a normal single document. So that's Sage worksheets. LawTech Editor. So this is similar to the RTech one I showed you, but just for normal LawTech. And this is meant to compete directly with Share LawTech, except that you have your full data in the file system right next to the LawTech document you're editing. It's very functional. For example, you can double-click on the right-hand side, and it takes you to the corresponding point on the left-hand side. You can open multiple simultaneous views on the PDF preview. If there are hyperlinks in the preview, you can click on them and they work. Everything can be reorganized however you want. So you can close everything, just have the text, and then maybe split it and have the preview on the left. And you have different types of previews and so on. So it's pretty powerful. If you make mistakes, it shows you a nice log of the mistakes and shows them in the margin, et cetera. And you can embed, if you say use package SageTech, then you can embed code in here. So what this will do is it will use Sage to factor the year and then show the result. So assuming I did that right. I think I did. Yep, see? So it's now factored 2018 and shown it to you. So it does that just because I wrote this in the LawTech document. So people use this a lot, like for example, when making homework assignments, they can randomize something at the top and then generate a LawTech document that gives you the homework assignment. The stopwatch says that we've been doing the demo for 7 minutes. Yeah, it's kind of handy to have a stopwatch. The funny thing is it also has time travel. So you can pause it, start it, stop it, over time and then see, I wonder how I used this stopwatch for the last couple of weeks. And you can see exactly how you've used the stopwatch. And there's, user-specific undo. Here's the command line terminal. Let me make this bigger. So you can type ls. These are all of our files. You can do things like use vim. You could say Jupyter console -- kernel equals Python 2, for example. And you'll run Jupyter in the command line. There we are. And then you can do 2/3 plus 3/2 and get 1, which mathematicians find pretty disturbing. There's a to-do list. I won't do much more with that. This is a course management system. What you do is you add students here. So I'll just type the name of a student. And you can have a couple hundred students, whatever. You can push out assignments to the students. The students work on the assignments. You collect the assignments. You can have them peer grade each other. You can grade the assignment and then push it back out to them. So it solves the problem of distributing and collecting homework. But the cool thing is, while the students are working on their assignments, since everything's collaborative, that's the main point of the talk, you have multiple people. You can see their cursor as they're moving, as they're working on the work. And the very last thing for the demo is that I want to show you collaboration. So I'm going to close all the tabs except the one with Jupyter. And then I'm going to sign in as a different user over here. Although, Jason, are you signed into CoCalc? Can I add you as a collaborator? OK, no, instead of me having to do 2 things. So Jason, my accomplice in the audience, I'll type Jason Grout right here. And it shows me, so this is how you add a collaborator. You go to settings, and then you type the name of somebody. It will prioritize people who you have current collaborations with or who are recently active. And so Jason comes up. If you want to be absolutely certain about the person you're adding, you can put their email address in instead. Click his name, and then invite him. And what he'll discover is he now has this project in his list. Right, Jason? Cool. And now Jason could do something like open the same Jupyter notebook. We can chat on the side. So I can write, hi, Jason. And notice there's a little J right here that indicates that Jason also has this document opened. And let's see. Oh, he just typed right there. There's his cursor. And he's running code. OK, so it's collaborative, multiple people at once. And you can look in the time travel, and you'll see that certain actions were done by Jason, other actions were done by me, et cetera. OK, so that's the demo. So hopefully now you have a pretty clear idea of what CoCalc is. Think of it as, it's kind of like Google Docs, but it's for technical people like us who use Jupyter notebooks and LawTech documents rather than people using Microsoft Excel or Microsoft Word. It's competing more with or providing more functionality in a technical direction. It's also fully integrates compute with the document. So instead of really separating the two, compute is really central because we have these terms. You're really using a Linux machine here. All right, whoops. Tmux. Top. So you can see it's a Linux computer. OK. It's collaborative, yes. Oh, so you can type, Jason can type something. If you want to quickly find, yeah, there you are. So there's Jason typing ls. I didn't do that. And you can also chat on the side. So, hey. OK. All right, so now let's go back to the talk. So first, the tech stack. How is this thing implemented? So if I was going to hire somebody, I'd really hope that they are really, really good with the following 5 things, basically. Node.js, so JavaScript on servers, PostgreSQL, PostgreSQL is a relational database that has really good support for push notifications. So you can have a change in the database, trigger a function, and then it sends a message out. And that's something we use critically in CoCalc in order to support real-time functionality. Python 3, we use that a lot for managing our backend infrastructure. React, so CoCalc is a React application. The whole front end is written in React, and TypeScript and CoffeeScript, which CoffeeScript was great in 2013 when I started CoCalc, but TypeScript is clearly the way to go today. And regarding ways to use CoCalc, so one way is you can use a Docker image that we provide. It's 100% free and open source. If you were to type exactly what I wrote right there and wait a few minutes, you would have CoCalc running on your computer, and it would also have a full LawTech installation there, Julia, Sage, et cetera. So it's like, it's going to be about 6 or 7 gigabytes with everything. And you'll get something running locally. It stores all its files in ~/CoCalc on your computer. And if you want to delete it and then upgrade it or swap it out, it'll still use exactly those files. So it's really easy to upgrade without losing your data. And you can directly access all the files that are in your projects because they're just in your home directory in ~/CoCalc. Another way to use CoCalc is via the website, CoCalc.com, which I was just demoing CoCalc at. This is used a lot, especially, so CoCalc, the primary user base is students in classes and their instructors. It's used a lot by professors at universities. I started it in order to solve a problem I had over the years repeatedly, which was I wanted to teach a course on computation related to mathematics. So I wanted to cover topics like Python, Sage, LawTech, R, just a whole suite of different data-related topics. And I taught a course doing that year after year after year, and the installation problem was really a nightmare. So CoCalc solves that installation problem. You can also install CoCalc directly on, on a Unix computer. This may be painful. I'm not claiming that's easy to do at all. I wish it were, but it isn't. Okay, so now you know what CoCalc is, and now I'm going to spend a few minutes telling you how real-time sync works in CoCalc. I make no claims that this is how real-time sync works in any other system, or that it's the best possible way to do it for Jupyter notebooks. If anything, I found that how you implement collaborative editing of documents depends an enormous amount on a whole bunch of different constraints you personally have, and the environment in which you're running in, the sort of documents you're editing, et cetera. Okay, so first in 2013, in a few days, I wanted to have real-time sync, and I thought it would be really, really easy because it'd been around in Google Docs for a long time at this point. And so I sat down, I looked at a lot of things, and there was Google Wave and all that operational transform stuff, which try not to, well, I don't want to say too much about that. There was also a paper and some talks by Neil Fraser, who had just went to work at Google on Google Docs on an algorithm he calls differential sync. And he had also written a really cool library called diff-match-patch, which does diffing of strings and creating patches from those diffs very efficiently in a whole bunch of different places. He implemented it in Python and JavaScript and in all kinds of places. And it's really designed for doing real-time collaboration. It's kind of like diff that you'd use on the command line, but instead of line level, it's character level. So it's critical to know about if you're going to implement real-time sync. Even if you're going to synchronize things other than strings, often complicated objects have strings in them, and you have to keep track of that. But I implemented this fully, ran it in production for about 3 years at scale, and ran into every possible miserable problem you could imagine. So I only implemented it for strings initially. So I wanted to synchronize things like IPython notebooks, Jupyter notebooks, and they are structured objects. So if you just try to naively synchronize them as if they're strings, you end up with merge conflicts that break the structure of being JSON. And so you end up having to deal with that in a number of ways, and it's quite painful. You can get it to work like 99% of the time. Once I was doing a demo, and the implementation worked fine for the most part, and I was like, hey, everybody, let's try to do this at once. And like half the class all had access to it, and there were maybe 50 people there. So they all tried to edit something, and when there was corruption at a local level in the document, there was some algorithm that would fix the corruption. but everybody's tried to fix the corruption simultaneously, which caused the corruption to get even worse, and then it blew up. And then anyone who even tried to open the file, their browser would hang. And there was also a notification encouraging you strongly to open the file. So you basically log into CoCalc, want to open this file, and then have your browser hang. And that wasn't good. So a lot of stuff like that can happen if you're not really careful. Real-time sync, it's like you kind of have this dynamical system that you hope when you iterate, things converge to some point, but they don't necessarily. Okay, these are some diagrams right here from the diff sync, or the differential sync paper. So you can see there's the text, there's a shadow of the text, there's this backup shadow, the server shadow. There's all these like different objects you have to keep track of. And there's protocols for what you do when things break and so on. So it's pretty tricky to implement. A lot can go wrong. And sorry, when I touch the screen, it keeps moving. And there's a big latency issue if you have more than like 2 or 3 users. So it's kind of like, it's a little bit like doing git commit, git pull, git push around in a circle over and over again. So, which is a totally, I mean, you could implement sync that way, but I wouldn't recommend it. The second implementation of sync that I did in CoCalc in 2016, I'm going to tell you exactly how it works, and that's in the next 2 slides. This slide just has a lot of text on it, but basically what happened was the following. An undergraduate was doing a Google Summer of Code project, and he wanted to add a slider, that time travel slider you just saw, to CoCalc back then. We didn't have any history of editing of documents. He just wanted that. I guess he was mistake prone and really wanted to know how to undo things. And he ended up having to implement something that kept track of all the changes to a document as the document evolved. And at the same time, I was switching CoCalc over to React, so we're rewriting everything from jQuery and HTML to React. And in React, there's a very similar problem where you have to keep track of the state of a document as it evolves. And there's a lot of use of diff algorithms and clever tricks to, computing a diff of two strings or more general structures. In general, can be very time consuming if you want to find like the optimal diff or the optimal way to transform one thing to another. But you can always just give up after a short amount of time and then choose a stupid way to convert one structure to another. So you can do really cool things by just not trying to find the best possible way to transform one structure to another. Just find a good one. So there's all these clever tricks that in programming that allow you to do things using new ideas that you'd like to do, et cetera. So in any case, at the same time as that, I also switched CoCalc to use RethinkDB, which is a database whose main sort of central idea is push notifications. What you do is you do a query, you subscribe to the query, and then anytime something changes, it tells you what the change is, which is a pretty cool feature. So here you are. So anyways, I rolled this out and implemented it, and it's a different way to do sync, and I'm going to tell you exactly how it works in a moment. Instead of differential sync, but the one sentence version of how this works is the following. You keep track of the changes that each user makes to the document. You broadcast them around. Everybody gets the changes, and then you put them in a log with a certain order. And then the definition of the state of the document at a given point in time is the result of replaying the log up to that point in time. It's a log structured, it's a log data structure. So applied to the problem of real-time sync. And it works really, really well for our situation. So now let me tell you exactly how it works in CoCalc. So the prerequisite is you need to have a way for clients to agree on a synchronized, consistent shared log. It's just a list of timestamp and a patch. So you just apply all those, and that gives you the current version of the document. There are various ways to do this, and of course the devil is in the details, to put it mildly, as far as implementing this goes. One is you can use one of these databases I just mentioned. I did use RethinkDB for a while. I rewrote everything to use PostgreSQL and its listen notify functionality because RethinkDB went out of business, and PostgreSQL is easily 5 to 10 times faster. So 2 good reasons. There's also Firebase from Google. They used to have something called Google's Realtime API, and somebody implemented real-time sync for Jupyter notebooks on top of that for Jupyter Lab at one point in time. This is a link to that, although Google deprecated it, so that's gone. The point of the database is it allows you to provide safe long-term storage for this list of pairs, a timestamp, and a patch. Because it's really, really nice that no matter what happens, you have the edit history of a document. Your file system blows up, something goes wrong, somebody accidentally deletes all their work. At least in the database, you have this immutable log, which is the history of editing the document. On the other hand, you could approach the whole problem by just using, say, Primus or some other WebSocket layer that gives you dedicated channels for each document. And you just push out a message, which is, hey, here's the change I made. It gets broadcast to everybody. And assuming no packets are ever lost, assuming nobody ever gets disconnected from their Wi-Fi, of course, those assumptions are false, then this would also give you a similar log. So you would have to deal with that problem. And in CoCalc, I'm currently combining both approaches. So the database approach is fully implemented and has been live for a couple of years. But I want to reduce the latency when you're doing real-time sync. And I'm doing that via also using a WebSocket channel to distribute messages. So that'll give me a really fast update. Then I'll distribute exactly the same messages via the database. That'll be slower, but it'll only be a backup in case of lost messages. OK, so here's the sync algorithm. This is the most important. Just notice the very bottom is missing. But this is the most important slide in the talk if you want to understand how CoCalc does real-time sync. And it's really just a review of what I just said a minute ago. So there's a log of patches. It's the time, the user, and an actual patch that you can apply to the document. It's good to include the user as well. I didn't mention that before. And the time and the user should be unique. And the state of the document at some point in time is just the result of you just order all the patches and you just apply them. You start with the empty document, just keep applying patches to it, and you get the current version of the document. So that's the data structure. That's all the communication that goes around. The only communication between the clients is a client, like your browser, sends a message saying, hey, here's a couple of edits that I made at these points in time. It sends them out, and then somehow they get broadcast to all the other clients, and then they get put in this log. And then all the clients, if everybody stops typing, all the clients will have exactly the same log, and they'll all be looking at the document that's the result of applying all the patches in order. So that's the entire algorithm. I mean, obviously, you need to figure out how to do all the things I said, and there's a couple of details there. But that's the sort of conceptual abstraction to think about. So the algorithm itself, when a user connects, they're going to put a timestamp on their patches. So you send them a message saying, here's the current time, and then you can do like a standard algorithm to try to make the time a little better. But it's OK if their clock is off by 1/2 of a second or a second or even 2 seconds. You just don't want the clock to be off by 30 minutes or something ridiculous. You could also assign times in the central server and then send them back, but that just complicates things a little bit. So what happens is the user is sitting there editing the document, and then periodically when they pause for a second, you take a diff from the current version to the version that they've now changed, and then you send a message saying, here's a change I made. And you just, that's sort of the active part. And then the other part is receive. Every once in a while, you get messages coming in. So you apply those. You just put them into your log, and then pause, and then the version of the document that the user's looking at is the result of applying all the patches. There's a whole bunch of algorithms you have to figure out based on this data structure. Like, how do you do user-specific undo and redo? How do you, if a user, basically you're getting all these patches, but they could be 30 seconds ago, 20 seconds ago. You stick them in the log, and now you have to efficiently figure out what the current version of the document is. So you'll want to cache cleverly recent versions of replaying the log. So there's a whole bunch of data structures and algorithms involved in doing that efficiently, and lots of chances to mess things up, because caching always results in bugs, so you have to be really careful. But that's the whole algorithm, and at least conceptually, it's easy to think about. And of course, it's very much inspired by how online video games work and stuff. One other thing is, what if you try to apply one of these patches and it fails? Well, in diff match patch, patches always apply on a best effort basis. So there's a parameter you give that's part of your algorithm, and it breaks, so a patch is a whole bunch of little changes you want to make with context. And if there's not enough context, given whatever parameter you have, it just fails little bits of the patch. It's kind of like in Git with patch, where certain parts of the patch don't apply. So in receive and update, you try to integrate your patch into the log, but if parts of the patch don't apply, you just throw away those parts. And this ends up meaning that like if two people are typing simultaneously in the exact same spot, somebody's going to win. Which one wins depends on the timestamp and how much of their patch got applied. But it is, once you know the timestamps, it's predictable. And everybody will agree on exactly the same current state of the document. Okay, so that's it. As far as what the algorithm is. But then there's more problems. What is a patch? What kind of documents do you have? And so you have to work that out. And so here, initially, I just synchronized text documents, but that's fine for editing source code and say markdown files where like any document is valid. But if you try to synchronize IPython notebooks, you end up very quickly with a corrupted and completely meaningless notebook. And that's not good. So here's what I did. So instead I came up with something basically motivated by using Cassandra a lot, which is like this object database that's distributed, which you define a table. You say, these are the primary keys for a table. And each row in the table, each object in the table, there can be at most one with those primary keys. And you can also specify things like this key, its value has to be a string. And when you do diffs and patches to a given object, you use the normal string diff match patch algorithm. It's very important because imagine somebody editing a Jupyter notebook. They're often editing a big input cell. Maybe it's 3 pages of code. They're making tiny little changes just to that text. So you don't want to send the entire text every time. You just want to send a little patch using the diff match patch algorithm to just that little tiny piece of the cell that they're editing. So you specify all that sort of stuff, and then you synchronize around these objects. So you make a notion of diffing and patching objects with a given list of primary keys. To make that very concrete, I'll show you how it works for IPython notebooks. So let's see, I want to zoom in a little without going to the next page. Whoops, dang it. Okay, there we are. So here, if you make a brand new blank IPython notebook, what I do is I take the IPython file and I translate it into a list of objects that are sync friendly. And here's a brand new blank IPython file. There's a cell with empty input, that's the first one, and it has position 0. The position is a real number, and the definition of the order of the cells is just you sort the positions. So if you take a cell down here and drag it to the top, it just sets the position of that one cell to be some small real or negative real number. And so you don't have to like do really complicated objects or operations involving moving objects around in your data structure. So you can forget about that. There's also just some additional meta information, and there's things like whether the kernel's running, what the kernel is, et cetera. And then there's a backend that knows additional information that makes it possible to save this back out to disk. So basically, you define a bijection between, or a mapping between IPython files and some other data structure that's very sync friendly, that's not a JSON file. Because it's really a fool's errand to try to do synchronization directly with JSON files. So you do all the synchronization with a small distributed object database. And then whenever the person wants to save the file to disk, you just export it back out to an IPython file. So you just define converters in both directions. If you type, it looks like it's 2 plus 3. I said 2 plus 2, but it's 2 plus 3. And then hit enter. Then here's how the, whoops, crap. Go back. Here's how the document changes. So now there's some output, and the input changed to 2 plus 3 from being blank. And it's the output messages, et cetera. And the other parts are basically the same. There's a little bit of information about memory and CPU usage. OK. And this is synchronized around to all the clients. And if you were to make a new cell, then there would be another object with type cell. It would have a different random ID, and it would have its input, its output, et cetera. OK. Here's some links to the source code. When you get my slides, which will surely be linked to from the page for the talk, you can click on these if you want to look at source code. And that's what I wanted to say about sync. And I have 5 minutes left. Let me stop for a second to see if there are any questions about how real-time sync works or any kind of clarifications you might want. And then I can show you a few other things. Yes? How does the poor user? It makes a new patch that's the undo. So, I mean, there's a lot of details there even, but you just take the thing that they want to undo, and then you apply it to the current state of the document to get a new version. And you have to keep track of, if they undo again, then you have to go back and see what the last thing they did in that session is, and then apply that. So you just apply, basically you apply the reverses of the patches of the things that they did before. And figuring out the reverse of a patch, well, that's easy. You just do a diff, but in the opposite order. So it's better to do that than to try to figure out by some clever trick what the reverse is. Yes? Oh, one other thing I should say. Immutable.js, which is a library from Facebook, which is used a lot in React, is super useful for implementing diffing and patching on arbitrary objects rather than just strings. So I forgot to say that. Yes? Does the Docker come with all the backend infrastructure as well? Yes. Yeah. Yep. The Docker, when you run that one line, when you type in that one line, it's fully up and running, has PostgreSQL running, et cetera. Yeah. And but it would be great if somebody were to actually use the Docker image besides me, because then maybe I get some pull requests and add some other kernels and stuff like that. So, and one of my employees, I've encouraged him to do a bunch of work on making the Docker image more friendly. So that's going to improve a lot in the near future. Oh, yes? As kernels get added, this feature is kernel independent. Yeah. Just making it work with that kernel. Yep, well, you don't have to do anything for particular kernels. Yeah. Let's see. I guess one other thing that's sync related I should mention, I did implement using classical plain vanilla Jupyter in an iframe with real-time sync. That's what we had up until 2017. It's still available and you can use it. It looks like, well, here's a slide about it. It looks like that. So it looks, well, it is just Jupyter. What happens is it loads Jupyter, it loads the JavaScript, and then it monkey patches the heck out of it to make it possible so that whenever the user changes a cell or changes anything, it pulls out the state of the document, does a diff, and then sends that diff off. And then it can do the reverse operation. And it does it on normal Jupyter notebooks. And it's so freaking hard to get to work reliably. So I deleted it and then had to bring it back because there were a few features of Jupyter that instructors desperately needed, like interactive widgets. So we don't have interactive widgets in our React rewrite yet, though I think we will within the next 2 weeks, because that's what I've been working on for the last few weeks. Okay. Since I still have a minute and a half, or 2 minutes, I'm going to show you just a bunch of pictures, screenshots I made. So this is classical real-time sync. This is what I just showed you. So the React rewrite of Jupyter. You can also, in a CoCalc project, there's a button. You click it, and it just pops up normal Jupyter in another tab. Just straight Jupyter. Obviously, it doesn't have real-time sync, but it's Jupyter. And it's on the same file system, in the same container. Sage worksheets, I showed you those. You can edit arbitrary code with the same, like being able to split the editor in multiple points. I'm working on VS Code language server protocol integration, so that VS Code will give you hints and so on. And that's needed for Lean, which is an automated theorem proving or proof assistant system I'm working on supporting for math classes. The LawTech Editor that I showed you, the command line terminal that I showed you, chat rooms, course management. This is a course management thing with a few more students. Here's a bunch of examples of how R is available in CoCalc. So you can use R with the Jupyter kernel. You can use R in a Sage worksheet if you put %R at the top of a cell. You can use R in the command line by just typing R. You can edit a file that ends in .r and it gives you nice syntax highlighting. You can use R Markdown, where you put the R code in the Markdown file and then it renders it automatically, so it runs it. And you can use R Tech, which I showed you a minute ago. So it's LawTech, but with R code inside of it. Okay, finally, to end, culture, there's a bunch of people and users. And finally, this is my very last slide, commercial versus academic. So other projects I've started or been involved in, like Sage and Jupyter, mainly not-for-profit academic projects, whereas CoCalc is commercial. So why? I had a lot of experience hosting online stuff at universities and did not, well, you get in a lot of trouble with your university and you get a lot of exposure. So, and it's a commercial project for various reasons. So I'm just going to stop because I don't want to run over time. So questions? Thank you. Yes?
You said on one of your pages that you're currently re-implementing, but you didn't say what technology.
So CoffeeScript, I'm rewriting all of our CoffeeScript code in TypeScript. Since CoffeeScript was a really good choice in 2013, 2014, TypeScript is clearly the way to go for a large JavaScript code base these days. So that's one thing that's being redone. Another thing is that sometimes our real-time sync will feel a little laggy, like it might take 2 seconds, and you want it to take 200 milliseconds. And I'm changing things to use a direct WebSocket connection straight to the project rather than going through the database. It'll still use the database, but only as a backup.
But you're still using React and Redux.
Yes, React and Redux are excellent. We're only using them more and more. React, Redux, TypeScript, et cetera, are our core technologies. I like React a lot. Yes?
What parts have you found to be the most difficult with the device? Where is it kind of struggled as you developed it?
So what is most difficult about this particular implementation of real-time sync? Probably the hardest thing of all was coming up with a good way of diffing and patching arbitrary objects and then actually just sitting down and implementing it fully rather than trying to fall back to just using strings, which didn't work so well. And it was nice to have worked. Oh, another big problem is IPython files can be really, really big, stupid big. So University of Sheffield uses R and CoCalc, and the first year that they used this, their students would make these 30 megabyte files. The IPython files would be 30 megabytes because they have tons of big SVG images in them. And we were trying to just sync those using diffing and patching as strings, and it was a total nightmare. So in that conversion from IPython file to this document database, we factor out all images and other large data that's attached to the IPython file and serve that via HTTP in a completely different way. So factoring out all large stuff is very important and serving it over a different channel. And users, like most of our students are like undergrads who just kind of do while true print. They make for loops that just burst a huge amount of output. And that might be okay on your own computer. You only hurt yourself. But over the web, it can be really painful because it can impact the other users. It can be really hard to get back into the project at all. It's a standard problem that you have to deal with. Jason. Right now, what happens is right here where it writes. So see right there, there's a little part in the document that's output and then a message or a list of messages. It just adds stuff to that. So the backend server just sticks stuff in the output part of the table. It just edits a particular entry in the document database. And then everybody sees the change and renders the output. So if there were 2 outputs in that cell, there would have been one labeled 0 and another one labeled 1 as the keys.
So you don't have a direct connection to the kernel. You're just editing the table.
Not right now. I know you're wondering about that to do comms, and I was working on that this week. There will be a direct connection via WebSocket that proxies comms. So we should talk about that later. Yeah. So I have not implemented real-time, or I haven't implemented interactive widgets in this yet. So that's a huge gapping, missing piece of functionality. So, all right, I'm definitely over time, but if you have any other questions, just come and talk to me. But talk to me today because I'm going to be leaving for the airport at 6 p.m. today. Okay, thanks.